Honors Pre-Calculus, this is your first video. This is section 3.4, solving exponential functions. There are two different techniques in solving exponential equations. Again, let's review what an exponential equation even looks like. Which is that there's no logs at all. And so now we're going to be solving for x. So the first way is called same base. And the base is b. If you can rewrite the bases with the same value, then you're going to use this technique called same base. Let's go ahead and go through a couple of examples. First example is 2 to the 3x minus 8 power equals 16. This definitely falls underneath the technique of same base. I'm going to be able to rewrite the 16 with the 2. So they both have the same basis. 16 is really 2 to the 4th power. So now I have an equal sign and both sides are supposed to be equal. Both of the 2's are equal, therefore both of my exponents are supposed to be equal. So I go ahead and I just set the exponents equal to one another. Then I proceed to solve for x. I am done. This is probably my favorite technique. It's nice and simple and straightforward. One for exponential called same base. Let's do one more example. Let's make it a little bit more dynamic. This is one of the homework problems. It says 9 to the x power equals 1 over the 3rd root of 3. So now you have to discover of whether or not you can write that with the same base. So 9, I replaced 9. So what I did is I took and I put parentheses around 9 and I rewrote that 9. 9 can be rewritten as 3 to the 2nd power. This one here, at first it was 1 over 3 to the 1/3 power, and then when you get that up in the numerator position, you're going to take the exponent of negative 1/3 and you're going to make it negative. So I guess I was able to take this original problem and have both of them have the same base of 3. So the first thing I'm going to do, a power raised to a power, I multiply, so there's no parentheses anywhere. So it's 3 to the 2x power equals 3 to the negative 1/3 power. So since this is equals and the bases are the same, I'm going to set the exponents equal to one another. So 2x equals negative 1/3. I'm going to multiply both sides by 1/2. And so the answer is x equals negative 1/6. Let's do one more problem. 8 to do the x plus 3 power equals 16 to the x plus 1 power. The 8 and the 16, I know I can rewrite both of them with a power of 2. So I will be able to use the same basis technique. So the first thing I did was I put parentheses around the 8 and the 16 and I rewrote it with the same base. 2 to the 3rd power, 2 to the 4th power. Next, a power raised to a power, I must multiply these. Not 3 times x, but 3 times x plus 3. 4 times x plus 1. So that's 3x and 9. That's 4x plus 4. Now I'm ready. The bases are the same, these are equal, so therefore the exponents must be equal. So I'm going to set the exponents equal to one another, and then I'm going to go ahead and solve for x. Again, I subtract 3x and I subtract 4, x equals 5. I am done with the first technique called same basis. Second technique, it's called different basis. And when you have to do this one, this is when you cannot write the exponential function with the same base. Then you must use this one, obviously called different basis. And what do you end up doing? You end up taking the log of both sides. So let's look at an example. First one is 4 to the x power equals 15. Sure, the 4 could be written as a 2, but there's no other way to write a 15. So I guess I have to use this technique called different basis, and what I'm going to do is I'm going to take the log of both sides. So the log of 4x equals the log of 15. Again, what is my goal? I'm trying to solve for x. But unfortunately, my x is trapped in an exponent position. Yet I'm supposed to solve for him. except now I have the power rule. With the power rule, I can bring the x down in front. By bringing the x down in front, it makes it much more doable. So this is 4 times this log, and this is just a calculator, it's just a number, and this is just a number. So let's just divide by log of 4, and I am done. And again, that has a base 10. I can put that in the calculator and get a numeric approximation. Let's do another example. I'm going to do actually 3 more examples. Here's the second one. This one says 7 times e to the 2x power minus 5 equals 58. Again, this is clearly not a logarithmic equation. This is still an exponential. I can see it, and where the x is trapped in the exponent position. So in order for me to work on this, I need to isolate my e to the 2x. So the first thing I'm going to do is I'm going to add 5 to both sides, and then I'm going to divide by 7. The 7 is multiplied to my e to the 2x. So now I have it down into the form like I did in the last problem. I have a base, I have an exponent, and I have an answer. But there's no way I can write this with the same base. So I'm going to have to use this technique number 2, in which I take the log of both sides. Because I see an e, I'm going to go ahead and take the natural log. So the natural log of e to the 2x equals the natural log of 9. Again, I'm solving for x, and he's trapped in the exponent position. But the beauty of the power rule is it takes it out of the exponent position, so I can solve this. So I'm supposed to be solving for x, so that means I just need to isolate it. So I need to divide by natural log of e and divide by 2. Except natural log of e, so that's e to what power equals e? 1. So I'm going to replace natural log of e with a 1. So 2x times 1 equals natural log of 9. So now I'm just going to divide by 2. So x equals natural log of 9 divided by 2. I have 2 problems left. Again, these are both written in exponential, not logarithmic, has a base with an exponent. Second, I cannot write the bases with the same base, so I must use technique number 2 called different bases. Since they both have the base already isolated on both sides, I can go ahead and take the log of both sides now. And I did. Again, I'm solving for x. Look at, there's an x on both sides of the equal sign, and on both sides they are trapped in the exponent position. So I'm going to use the power rule on both sides, but you need to be very careful. This is the entire power, and this is the entire power. So I did bring it down in front, and I clearly showed with all the parentheses I need to be careful. Again, I'm solving for an x. I have them on both sides. This is now distributive property. So let's go ahead and do that distributive property. 2x times log of 3, negative 1 times log of 3 equals x times log of 7 times positive 1 times log of 7. Now I have 4 terms. There's no parenthesis. If I'm solving for x, I need to get both of the terms that have an x in them on one side and the ones that are just numbers on the other side. So I did that. Brought this term over here, now it's negative. Brought this negative term over here, now it's positive. Both of these terms have an x, so now I can factor out that x, which that is exactly what I did. I factored out that x. It's x times this, and all of this can just be numbers, and these are all just numbers, so why not just divide by those numbers, and I have solved for x. I have one last problem. Sorry. Here's my last problem. This looks completely different. Clearly it's not logarithmic, except now I have 2 bases with exponents having x's in them. So I have three terms here. It's set equal to 0. This one doesn't even have an exponent. This one is 2x. This is x. So this kind of looks like a quadratic. This kind of looks like a quadratic. In fact, I'm going to play with it and see if I can get it to factor. So I put my two sets in parentheses, and I asked myself, what times what gets me e to the 2x? Well, e to the x times e to the x. When the bases are the same, you write down the base and you add them. X plus x is 2x. Oh, that was true. That's a negative 7 to the ex. This is a negative 1 to the ex. You add that, you get negative 8 to the ex. And then negative 7 times negative 1 is 7. So again, I had two bases with exponents, but it looked familiar to me. It looked like a quadratic, and it was able to fit. So now I'm going to set each of these factors equal to 0, just like what you do with a quadratic. Now I need to go ahead and add that 7 and 1. So it's now ex equals 7 and e to the x equals 1. So I'm going to take the natural log of both sides. I have both equations going at the same time. I have x trapped in the exponent position. I need to go ahead and get that down, and I did. Let me turn this paper so we're not confused here. So I brought it down so I can solve for this x. I brought it down so I can solve for this x. But again, natural log of e to what power equals e to the first power 1. So I can substitute this for 1 and substitute this for 1, which is what I did. But, sorry, that's just a parenthesis I didn't mean to write. Natural log of 1. That's e to what power equals 1? 0. Replace that with 0. So this is x equals 0, and this is x equals natural log of 7. Thank you.